that is x power n minus a power n by x minus a, and when you apply the limit as x tends to a, then it is equal to n into a to the power n minus 1. After applying the definition, f of x plus h should be written in the form of sin x plus h. 1 by cos means secant x, 1 by cos square means secant square. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous session, we have learned how to derive a given function, that is finding the derivative of a function using the first principle method. In this session also, we will be continuing to find the derivative of a function of a polynomial function as well as a trigonometric function using the first principle of derivative. And we are discussing about the algebra of derivatives of function. That is, whenever two functions in the form of addition, subtraction, multiplication or quotient form is given, then how to find the derivative of those functions. So let's start today. First, finding the derivative using the first principle method. The very first question here I have taken is f of x is equal to x to the power n. So, whenever they ask you to find the derivative of any function using the first principle, the very important thing is you should first write the definition of the first principle. That is, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x whole divided by h. So this is the first thing you have to do. As I said earlier, this type of question carries 3 marks in your examination. Any function can be asked to derive using the first principle of derivative. So first write the definition, then write on the function in the form of x plus h as well as f of x. Now f of x is x power n, then f of x plus h is x plus h whole power n. Now f of x is as it is given here, so it is x power n. Next, divided by h. What I'll do here, I will add x and subtract s so that it looks same like x plus h whole power n minus x power n, x plus h minus x. We have discussed previously, that is limit of the form as x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. So we have discussed this proof. Any expression of this form, that is x power n minus a power n by x minus a, and when you apply the limit as x tends to a, then it is equal to n into a to the power n minus 1. So now this equation looks in this form, that is x power n minus a power n divided by x minus a. Now anything can be written in the form of n into a to the power n minus 1. So the value of n is same here, but a, in the place of a you have x, so replace with x, then write n minus 1. So the reason must be written to prove this result. So the derivative of the function x to the power n can be written as n into x to the power n minus 1. So this is also called as the general form of the derivative of the function x power n. For example, if any function of the form y is equal to x power n, as I said dy by dx, we got it as n into x to the power n minus 1. So in our previous session, we have derived the expression for x square. So x square, we got the derivative of 2x. Using this formula also, it is similar. So if it is x square, then it is 2 into x to the power 2 minus 1, which is same as 2x. So in general, any function of the form x power n, it may be a positive power, a negative power, anything. So its derivative is always given by x to the power n minus 1. Again, suppose if you have root x. Now we know that root x is nothing but x to the power half. So any x to the power half, using this formula n into x to the power n minus 1, we can write the derivative as half into x to the power half minus 1, which is 1 by 2 root x, because it is x to the power minus half. When it comes to the denominator, it becomes x to the power half. Again, you can convert it into 1 by 2 root x. So all these answers you will get in this form. Therefore, any function of the form y is equal to x to the power n, its derivative is always given by n into x to the power n minus 1. You can directly write the result. But whenever they ask you to find the derivative using the first principle, you have to follow this method. That is, first write the principal derivative definition, then substitute the function in the form of x plus h and x. Then you can make the conversions and apply the limit to get the answer. Next, we are taking one more function which we have already discussed, that is f of x is equal to sin x. In our previous session, we have found the derivative of sin x at the point x is equal to 0. So there we have used the basic definition. Now here we are using the principal derivative, that is first principal derivative. So again, apply the definition here. After applying the definition, f of x plus h should be written in the form of sin x plus h. Now you get this as sin x plus h minus sin x. Now using the transformation formula, that is sin x minus sin y. So sin x minus sin y is nothing but 2 cos x plus y by 2 and sin x minus y by 2. So using this transformation formula, you will get the next step, that is 2 cos x plus h by 2 sin h by 2. How you will get this? You can just verify here. You have this in the form of sin x plus h minus sin x. Now when you write this, this is 2 cos x plus h plus x by 2 sin x plus h minus x by 2. So here you will get 2x. So 2x when divided by 2, it becomes x plus h by 2 into plus x minus cancels. So sin h by 2. So this is how you got the result for this step. So you can directly skip all those steps and write directly, that is sin x plus h minus sin x is equal to 2 cos x plus h by 2 sin h by 2 divided by h in the denominator. The next step is, now we know that limit of x tends to 0, sin x by x is equal to 1. Now here we have it in the form of sin x, but here the 2 is shifted in the denominator so that it looks in the form of sin x by x. So therefore, sin h by 2 separately you take in the denominator h by 2 and leave the rest of the thing separately. Now apply the limit as h tends to 0. When you apply the limit as h is equal to 0, cos x plus 0 by 2, which is 0 here. And when you apply limit for this function, since this is in the form of sin x by x, its value is equal to 1. So therefore, the value is cos x. Therefore, the derivative of the sin x function is cos x. So this is using the first principal derivative. So the derivative of sin x is cos x. Next question, I have taken the same for cos x. Let us see what I will get for cos x. So again, apply the first principal derivative definition. Substitute f of x plus h in the form of cos x plus h. Replace x by x plus h in the given function. Then you will get it as cos x minus cos y. Again, using the transformation formula, cos x minus cos y is nothing but minus 2 sin x plus y by 2. There you will get 2x plus h. 2x by 2 will become x and h by 2. X minus y by 2. So x cancels, h remains. Again, apply the same property. Shift 2 to the denominator. Separate sin h by 2 by h by 2 and sin x plus h by 2. Now apply the limit as x tends to 0 by taking minus outside. So when you take minus outside, substitute h is equal to 0 here. this will become 0. Therefore, it is sine x plus 0. And when you apply the limit for this function, this is the standard form of sine theta by theta, whose value is 1 when you apply the limit as x tends to 0. So, therefore, this value will become 1. Now, you have this sine x into 1, which is sine x, but outside you have negative. So, therefore, it is minus function. So, therefore, if y is equal to cos x, then dy by dx or f dash of x is equal to minus sine x. That is, the derivative of cos function is minus sine function. Next, I have taken tan x function. Again, apply the same method. First principal derivative definition. F dash of x is equal to limit f of x plus h minus f of x by h as h tends to 0. Now, put this as tan x plus h minus tan x. So, as I said previously, whenever you get any tan function or cont function, replace it by sine by cos so that it will make your simplification easier. So, therefore, I have taken tan in the form of sine by cos. So, this becomes sine x plus h cos x plus h minus sine x cos x. Now, taking the consideration of fraction, we will get sin x plus h into cos x minus sin x into cos plus h divided by h in the denominator. Here you have h, which I have taken outside here. Now again I am multiplying it inside. Now cos x plus h into cos x. Now you can see this is in the form of sin x cos y minus cos x sin y. What is this actually? Sin x cos y minus cos x sin y, which is sin x minus y. That is difference of two functions in terms of sign. So therefore, in the place of this equation, I have replaced this in the form of sin x plus h minus x. So this is how it looks. And the denominator value is same. Here plus x minus x get cancels. Now in the numerator I have left with only sin h. Therefore, I have made it separately in the form of sin h by h and the other part of the denominator separately in the form 1 by cos x plus h here, h into cos x. Now apply the limit as h tends to 0. When you apply the limit for this function, this value is 1. And when you apply the limit for this function, h value is 0. So therefore it is cos x into cos x, which becomes 1 by cos square x. We know that secant function is the reciprocal of cos function. So therefore 1 by cos means secant x. 1 by cos square means secant square. So therefore the derivative of the tan function is always secant square x. So if y is equal to tan x, then we can write dy by dx is equal to secant square x directly. So again, when they ask you to find the derivative of tan x using first principle method, you have to follow this method completely. But when it is for 1 mark or 2 marks question, you can directly write y is equal to tan x in the form of secant square x directly. Now this is how we are going to the derivative of a function using the first principle of derivative. Let's look at the algebra of derivatives now. So here it is in the form of the theorem. Let f and g be two functions such that their derivatives are defined in a common domain. So this is possible when they are defined only in the common domain. Then derivatives of sum of two function is sum of the derivatives of the function. So we have sum of two function which is equal to sum of the derivatives of the function separately. And it is applicable same for the difference of two function. That is, derivative of difference of two function is equal to the difference of derivative of two function. I'll take an example now. So let me take f of x is equal to x square plus tan x. Now I have to derive this function. So I can write it as dy by dx, or you can write in the form of f dash of x also. Okay, so now derive x square, d by dx of x square plus d by dx of tan x. That is, we are deriving the function with respect to x. Now, it is in the form of, what is the general form of x power n? If y is equal to x power n, then dy by dx can be written as n into x to the power n minus 1. For cos x, it is minus sin x. For sin x, it is cos x. For tan x, it is secant square x. Whenever these type of question is given to find the derivative, directly write the derivative value. Now, here I have x square form. So, if I write this in the form of n into x power n minus 1, it is 2 into x to the power 2 minus 1 plus, what is the derivative of tan x? Secant square x. So, the answer is 2x plus secant square x. So, this is the derivative of the given function. So, whenever the two functions are given in some or different form, then derive it separately. I'll take you one more example. Let y is equal to x minus sin x. So, now the power of x is 1. So, whenever the power of x is 1, the derivative of this function is always 1, or you can directly write x1. When you apply the same result, it is 1 into x to the power 1 minus 1, which becomes 0. Therefore, the derivative of x is always 1. Now, sin x is cos x. So, simple. Directly write the derivatives of the given function. So, derive separately the function whenever it is given in the sum or difference form. Next, derivative of product of two function is given by the following product rule. So, here we have two functions in the form of product f of x into g of x. Whenever the function is given in the form of products, you have to follow this rule. That is, first function into derivative of second plus second function into derivative of first. That is, you should keep the first function, derive the second function plus second function, derive the first function. Let us take an example now. So, let y is equal to x into cos x. So, as I already said, the derivative of x is 1 and derivative of cos x is minus sin x. If you don't know the values, write it separately. The derivative of x is 1 and cos x is minus sin x. Now, since this is in the form of product, we should follow this rule, which is called as product rule. So, what does product rule says? Dy by dx is such that first function write as it is, derive the second function, that is d by dx of cos x, plus second function keep cos x and derive the first function, that is d by dx of x. Now, x cos x is minus sin x plus cos x, derivative of x is 1. So, the answer is minus x sin x plus cos x. So, this is how we are going to derive the function when it is in the form of a product. Next, now what if it is in the form of quotient, that is in the form of a fraction, that is f of x by g of x. Both are two functions, but it is in the form of quotient. Now, again, here we have a quotient rule. What does quotient rule says? Quotient rule says second function derive the first function minus first function derive the second function whole divided by square of the second function. So, this is what the quotient rule says. That is, second function into derivative of the first minus first function into derivative of the second divided by square of the second function. Let us apply this quotient rule. So, let me take an example. Y is equal to sin x by x square. Sin x by x square. We have two functions. One is sin x, another one is x square. Now, it is in the form of a quotient. So, let us apply the quotient rule. So, therefore, dy by dx is equal to, what does quotient rule says? First, second function, derive the first function. What is my second function? X square into derive the first function. Here it is sin x minus first function into derive the second function whole divided by square of the denominator. Denominator is x square. Take again the square of the denominator. Now let us write the derivatives of the given function. Here it is as it is. Derivative of sin x is cos x minus sin x. Derivative of x square is 2x. You can use the formula n into x to the power n minus 1 also. Whole divided by x to the power 4. So here you can observe x is common in both numerator and denominator. When you take x outside here, this becomes x cos x minus 2 sin x whole divided by x cube. This is the final answer. So in the numerator, x outside, again in the denominator 1x outside, so it gets cancels. So you are left with x cos x minus 2 sin x divided by x cube. So this is how we are going to find the derivative of any two function when it is in the form of quotient by applying the quotient rule. So this is about the algebra of derivatives. Now we have some important standard results which the derivatives of the function found using the first principle of derivative. Now suppose if you have any constant, I already said when you derive any constant, its value is always 0. You can find by using the first principle of derivative, you can verify it. Therefore, the derivative of any constant function, whether at any numerical value or pi or e, all values is 0. Next, this we have found now. Any function of this form, its derivative is always given by n into x to the power n minus 1. We can find, suppose, what is the derivative of 1 by x? Using first principle method, we have already found the derivative of 1 by x as minus 1 by x square. But let us check using this formula now. 1 by x can be written in the form of x to the power minus 1. So whenever you have in the form of x to the power n, its derivative is given by n into x to the power n minus 1. So therefore, dy by dx is n into x to the power n minus 1. Apply the formula. So it is minus x to the power minus 2, which is 1 by x square. So you can see both answers are same. So using this formula, you can find the derivative of any power of x. Next, this we had proved dy by dx or derivative of sin x function is cos x. Derivative of cos x function is minus sin x. Next, now derivative of tan x is secant square x. Secant x is secant x tan x. So learn these results. This you have found using the first principle of derivative. Next, derivative of cosecant function is minus cosecant x cot x. You can verify all these results from the first principle of derivative. Next, derivative of cot x function is minus cosecant square x. So, these are the standard results of certain functions which we found using the first principle of derivative. So these are the standard result which you have to learn when you are deriving the functions. Next, we have a Leibniz rules for differentiation. What is this Leibniz rule? It is same as the algebra of derivatives. That is, whatever the function you have taken in the form of f of x and g of x, here it is replaced by u and v. What does this Leibniz rule says? The first rule is for the sum and difference of two functions when you are deriving. So when you are deriving or differentiating any two function in the sum or difference form, then differentiate it separately. That is, whenever you are deriving a function d by dx in the form of f of x plus or minus g of, what you are supposed to do? You are differentiating it separately. That is f of x one times and g of x one time. Similarly, here f of x and g of x is replaced by u and v. What does this says? If you are deriving a function in the form of u plus v or u minus v, then it is u dash plus v dash or u dash minus v dash. That is, as in this case, it says d by dx of f of x plus or minus d by dx of g of x. So you are deriving the function separately. For example, if you take x plus sine x as y, then what is dy by dx of x plus sine x? Dy by dx of x plus sine x. Derive it separately, the rule says. So differentiation of x is 1 and differentiation of sine x is cos x, or derivative of sine x is cos x. So the answer is 1 plus cos x. If you have minus here, then the answer becomes 1 minus cos x. Next rule says when you have a constant along with the function. For example, I'll take y is equal to 3 tan x. I know the derivative for tan x, that is secant square x. But what is 3 tan x? What does the rule says? When you have any function with the constant, keep the function separately and derive the function separately. So what you should do here, dy by dx for this function, according to the rule, keep the constant outside. So write 3 as it is. Derive only the given function. So what is the derivative of tan x? It is secant square x. So therefore, the derivative of 3 tan x is 3 secant square x. So whenever you come across constant along with the function, write constant as it is. But when you are deriving only constant, its value is always 0. Next, the product rule, as in the case of f of x into g of x. What does it say? First function into derivative of the second plus second function into derivative of the first. So for your purpose, you can learn this as a formula. uv whole dash is uv dash plus vu dash. Wherever dash represents, you are deriving the function. So write the derivative of the function. So u as it is, v dash means derivative of second function you have to write. U dash means derivative of first function you have to write. Next is quotient rule. So quotient rule again in the form of f of x plus g of x. Quotient rule means the function in the form of f of x by g of x. So replace it by u by v. Then derivative is d by dx is replaced by the dash here. What does the rule says? Quotient rule says second function derivative of first function minus first function derivative of the second function over the square of the second function, that is the denominator square. So that is equal to, when you replace or learn it as again in the form of a formula, u by v whole dash can be written as vu dash minus uv dash divided by v square. So these rules are applied whenever you are deriving any function of these forms. So all these rules are necessary when you are deriving the functions. So in today's session, we have learned how to derive the functions using first principle of derivative. All the derivative of a function can be found using the definition of first principle of derivative. And by using first principle of derivatives, we have already found some standard result for trigonometric function and some polynomial function. Those standard result along with the Leibniz rule helps us to find the derivative of a function. We'll solve those problems using the derivatives rules in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.